Welcome to this exciting video on the structure of benzene. Benzene was first discovered by Michael Faraday in 1825, though its structure baffled chemists for many years. In 1865, Frederick Kekulé came up with a sensible structure of benzene from a dream about a snake eating its own tail, a cyclic structure with rotating single and double bonds. Though there are some problems with this form. First, it suggests that benzene should react similar to ethene and undergo addition reactions, but instead undergoes substitution. It would also suggest that it was an irregular hexagon, as the bond lengths differ, when we know it's a regular hexagon with intermediate bond lengths between single carbon bonds and double carbon bonds. The final problem with this structure is that it would suggest that benzene is less stable than it is, as Kekulé's structure would suggest that the energy given off to form cyclohexane would be 3 times as great as what it would be for cyclohexene, which in fact it isn't, meaning more energy is needed to break the bonds, meaning the structure of benzene is more stable than Kekulé predicted. Kekulé answered these problems with suggesting that benzene was moving in rapid succession between two forms. The modern day view is similar to that of Kekulé, except the added delocalized electrons to the model. In today's model, we know that in benzene the carbon atoms have 4 unpaired electrons, 1 in the s orbital and 3 in the p orbital. The s orbital and the 2 of the p orbital hybridize to form an sp2 orbital, which forms sigma bonds with the hydrogen and 2 other carbon atoms within the benzene. The remaining p orbitals of the carbons overlap on both sides to form a system of pi bonds, creating a ring of delocalized electrons above and below the ring. This solves all of Kekulé's problems, as all the bonds are the same, the delocalized electrons offer extra stability to the structure, and this also makes it reluctant to undergo addition reactions. Thank you for watching this clearly wonderful video on the structure of benzene.